Hi everyone, I'm Dr. Manjula Sri, professor in the Department of Electronics and Instrumentation Engineering. I'm going to deliver the lecture series in computer organization and design. And today's lecture covers the introduction to the computer organization, the basic computer, its instruction formats, addressing modes, and the instruction set. So let's go to the fundamentals, like what is, before going to the basics of the computer organization, let us see what is computer organization, what is computer architecture, what is computer design, and computer architectural design. So computer organization means it concerns the way in which the hardware components operate and the way they are connected to form a computer system. Computer design is hardware design of the computer, what hardware should be used and how they should be connected is described by the computer design. Computer architecture is how the structure and behavior of the computer are seen by the user. And computer architectural design mentions the specifications of various functional modules and structuring into a computer system. So this is the basic difference between the computer organization, computer design, and computer architecture. So coming to the functional block diagram of a computer system, we all know that the major components are the central processing unit, the memory unit, the input-output units. So the central processing unit consists of two subparts like control unit and arithmetic and logic unit. Basically, the central processing unit is the brain of the computer, where the arithmetic and logic unit will be performing all the operations which are arithmetic and logical, whereas the control unit will be generating control signals in order to perform these operations. Memory unit is required in order to save the program as well as the data. The instructions will be fetched from the memory one after the other, and then they will be executed in the central processing unit, and the result will be again saved back into the memory as well as it will be displayed to the output unit. The input devices are used in order to give the data as well as the program to the system, whereas the output devices are to present the output of the program or whatever we wish to display or save, that will be given to the output device. Then usually the input devices we come across are a keyboard, mouse, mic, and many more. Even optical devices can be used, joystick can be used, like that. There are many devices that are used. And the output devices typically will be using a monitor, a speaker, headphones, a printer, etc. All these can be used as output devices. Coming to the instruction set architecture of a CPU, how the user can view the CPU, how it can perform its functions is said to be the instruction set architecture. So in this lecture, we'll be discussing about the basic computer organization and design, where the basic computer has been hypothetically defined by Morris Mano in their lab. And the basic computer has two components, a processor and memory. If you look at the diagram, there is a CPU and a RAM. So the memory has a capacity of 4096 words in it, and each word has a width of 16 bits long. So it is very small memory, said to be 4K. Then the basic computer follows a stored program concept. So stored program concept means the program as well as the data are stored in the memory, and the processor will be fetching the instructions from the memory and executing one after the other. So this is what is said to be the stored program concept, and program is nothing but a sequence of instructions, and every instruction is nothing but a group of bits that tell the computer to perform a specific operations. So each and every operation will be defined with an instruction. So the operands can be changed. The operands can be memory locations or the registers. and the content, the data can be put in the memory locations or can be transferred into the registers also. And coming to the memory, the CPU reads the next instruction from the memory and it will be placed in the instruction register. So instruction register will be given to the control unit where it will be decoding the instruction. So the instruction register holds the instruction that is fetched from the memory. The control unit will be decoding the instruction and divides that into a sequence of micro operations in order to implement it. Something like if you want to transfer a byte of data from memory to one of the registers, so it will be divided like it should be first transferred into the bus structure and then into the specified register. So in that way they are divided and then will be implemented. So whichever hardware modules need to be activated, the corresponding control signals will be generated by the control unit. Then coming to the basic computer registers, there are a few registers which are of 12 bits and 16-bit registers, and a few are 8-bit registers. If you look at the diagram, it has a memory of 4096 by 16 and few registers. They are named like PC, AR, etc. PC stands for the program counter. Wherever we see that there are 12-bit registers, the meaning is that they are meant for holding the address. If you look at what is the size of the address bus, see the RAM capacity is 4096 locations, 4K. 4K can be expressed as 2 to the power of 12. 4 is 4096 is expressed as 4 into 1024, where it is expressed as 2 power 2 into 2 power 10, which is 2 to the power of 12. So the meaning is that it requires 12 bits to address each and every location. So any location that I want to access, I will be using an address of 12 bits. So that is what I mean by the registers which are of 12 bits are meant for holding the address. So program counter is meant for holding the address of the instruction, and address register will be holding the address of a memory location, whether it is for fetching a data or fetching an instruction. So if you look at this, like a PC is program counter, it holds the address of the instruction, whereas the address register usually we mention as holds the address of memory. So why this distinction is, when we are fetching at that time, the address will be transferred to a program counter. Whichever instruction is to be fetched next, that will be transferred first to the instruction, to the program counter. Then it will be fetching the instruction and brings that and holds in instruction register. So instruction register will be holding instruction. If you look at again the memory size, the width is 16 bits. 0 to 15 means it is of 16 bits. So whether it is storing an address or whether it is storing a data, it is of 16 bit long. So instructions will also be of 16 bit long. Data will also be of 16 bit long. Any of the bits that are not used will be kept as zeros, most significant bits. So coming to the other registers, instruction register, just now I told like instruction is of 16 bits which will be fetched from the memory into this, and its address will be held by the PC, program counter, right? So instruction will be fetched into instruction register. From there it will be sent to the CPU for execution. Then other registers available are TR is temporary register, that is usually used for holding the data temporarily, and data register is meant for holding the data. Okay, we fetch instructions as well as data. Data is nothing but the operands. Instruction is the system instruction, whatever opcode we use, that one. Then AC is accumulator. Usually accumulator register is the basic register which is meant for utilizing in all the operations. In most of the basic computer operations or commands, they are associated with the accumulator. Even it is a memory reference instruction or a register reference instruction, one of the operand would be available in the accumulator. So any operation is performed through accumulator, and this is the register which is connected to the ALU, one of the register. Then the other registers that are available are out or stands for output register, and this is input register. Input register and output register are meant for holding a character from the input device. When a input device is connected sending a character, that will be stored initially into the input register when it is coming to the processor. Similarly, when an output character is to be sent to be displayed on the screen or so on an output device, then that will be kept before sending to the output device in the output register. So these are all meant for a character by character the data will be input or output. So when we say like an ASCII character, ASCII keyboard, from ASCII keyboard, the 108 key keyboard is an ASCII keyboard. So each letter whatever we have is represented with its equivalent ASCII code actually. So which will be converted into hexadecimal code when a character is to be input or to be out. Okay, so when from the keyboard, the ASCII keyboard, when we are reading a key, the ASCII character code which is printed on the key would be converted into a hexadecimal code and then into binary. Actually, it is converted into binary. Machine understands only zeros and ones. When we say zeros and ones, and if I want to represent 16 bits at the same time, then it is a laborious process. To avoid that, what I do is I will be grouping 4 bits as one digit, which is a hexadecimal digit. So that hexadecimal digit can be expanded as a binary bits. So it will be converted into machine language. Zeros and ones is nothing but the machine language. So whenever we say a input device, its function is to read the data whatever it gives in the format it gives, and it will be converting that into machine understanding format into zeros and ones. And not the keyboard alone, we can we can connect some sensors, maybe a temperature sensor. Its output will be different. It is not a number or anything. It will be an equivalent voltage that will be given in terms of, in place of the temperature. Then that number, that voltage level will be converted to digital, and that digital data will be given to the processor. All that will be taken care by the input interface or the input device itself. So this is the purpose, like why we'll be maintaining a separate module as input unit and output unit. So it will have an input device as well as the input interface. Similarly, the output also. When we want to display the data on the screen, what we do is the characters will be sent. It will be sent again converted into ASCII character. Whatever characters we read as ABCD, 1, 2, 3, 4, special characters, all these are ASCII characters. So they will be again converted. The machine code again will be converted into ASCII and will be displayed. So coming back to the registers, like these are all the basic computers registers which will be performing the function assigned. And how are they connected and how are they selected? If you look at the diagram here, the system uses a common bus. When we are coming to the common bus or the bus system, basically all the architectures are divided into 2 categories: von Neumann model and Harvard model. In von Neumann model, we will be using a same single memory meant for holding, saving data as well as program, and also a common bus in order to transfer the instructions as well as the data. Whereas the other category is the Harvard model, where it will have exclusive memory for data and another memory for the instructions. And the bus structure is also different, like from data memory, data bus will be there, and from instruction memory, instruction bus will be there. Separate buses will be used, which can be performing the operations, transferring data as well as instructions parallelly. So whereas von Neumann model is a basic model which is economical compared to the Harvard model, but that was the faster compared to the von Neumann model. So this basic computer by Maurice Mano is also according to the von Neumann's model. So this is using a common bus system where all the components whichever are going to transfer the data or instruction are connected to the same bus. So if you look at this diagram, so we have a memory unit connector. So this outer line, whatever is shown here, is a common bus, and this is the memory. And if you look at the other modules are nothing but registers. This is address register, program counter, data register, an accumulator which is connected to the ALU, arithmetic and logical unit, and input register, all are connected to the same bus. Then in order to choose any of the register, for example that I want to transfer some data from memory into accumulator register or any other register, let us say, then the processor will be generating a control signal to select one out of these. So S0, S1, S2 are the select lines, so with which we can have 8 combinations. So 0, 0, 0 combination is not used, but all other combinations, when this is 0, 0, 1, 0, 1, 0 up to 1, 1, 1. So for each of these combinations, one out of these AR or PC, DR, AC, IR or temporary register or memory, any one of these will be selected. Suppose like to perform or to transfer data from memory to into any of the registers, what is to be done is one of the registers load signal will be, load means to load some data from the bus onto the register. So that load signal, any of the registers load signal, if you observe every register will have a load signal. So that will be made active, or in a next cycle the read control signal of memory unit will be made active. So when these are made active, like in one cycle the content from memory will be read onto the bus, and in the next cycle, clock cycle I mean, so the data whatever is available on the bus would be loaded into the respective register whose load signal has been made active. So in that way the data transfer takes place, making use of a single bus by choosing one out of many registers or the memory through the select lines S0, S1, S2. So that will be done by the control unit. Then coming to the basic computers addressing modes, what is an addressing mode before that? So addressing mode is nothing but how an operand in the memory is addressed. How are you mentioning that? So coming to the basic computer, there are only two addressing modes that are used. One is the direct address mode and the other is the indirect addressing mode. So the address in memory of the data to use will be mentioned in the instruction itself. In direct addressing mode, the address of the operand wherever it is available will be available in the instruction itself, that will be mentioned. Whereas in case of indirect addressing mode, the address in memory of the data. So in indirect addressing mode, address of the operand will be available in another location. That address will be mentioned in the instruction. So whatever is mentioned in the instruction with indirect memory address is address of the data operand. So in that way, like it is indirectly. If you look at the diagram, so first one, if you look at, here is the operand and the instruction is 0, the last bit. This is of 16-bit width, and this most significant bit 0 indicates that it is a direct addressing mode. This add is an instruction and it has to add the contents at 457 memory location to the accumulator. That is the meaning of this instruction. What is 457 is, I discussed like the address is of 12 bits. Instead of representing 12 bits, the 12 bits can be divided, the 12-bit address can be divided into 3 digits of 4 bits each. 4, 5, 7. So if we expand each of these digits, that is a hexadecimal, and 3 4s are 12. So 12-bit address refers to the memory location where the operand is available. So this is directly mentioned. This address is directly mentioned in the instruction. That is what is direct addressing. Whereas in the indirect addressing mode, this is the instruction. This one tells that this is an indirect addressing mode, and the other operation is like add some content from memory to the accumulator, which content pointed by this address will be pointing the address of the operand. So 300 is here and 300 is containing some other address. That is what is meant by indirect addressing. This will not mention the address 1350. 1350 is the address of the operand. The instruction will not mention 1350 directly, but it will mention where is that address available. That is what is meant by indirect addressing. So in this way, like beyond the capacity of memory, we can mention some addresses. That is the advantage. And the address that can be directly used without modification to access an operand for a computation is said to be the effective address, or if the target address is a branch type, that will be calling as an effective address. Thank you so much. The contents of this topic are taken from the Computer System Architecture by Maurice Mano. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.